Good afternoon, students. How are you?
Afternoon, sir.
Wow, this is I'm at a conference and my watch. Oh crap! This is gonna. Oh Lord, help me. Alright, so I'm at a conference and my watch is telling me the time. It is still saying 5 minutes past. Outside of Excelsior from college. But so them claim, yes sir.
Ocean Coral Cliff?
Yes sir.
Oh. Oh, if it's down here, that's why I asked. You just presented to.
You serious?
Yeah, man. She and Mr. Silpot.
It's she I was talking to because Matthew asked me a while ago because I know Matthew pretty well.
Right.
And Matthew asked me, I said, Shandy, you check in already? I said, Matthew, from morning, and I just got into the room, which is I'm now coming to class. And he was walking with her. No, I know. You bugger you? Yes, man. Okay, cool, yeah.
Yes, sir.
Nice. So I am here, but it's this is my second time coming here, and the experience. I thought this one here now would kind of wash out the one I had before, and it just never. It's even complicating it, make it feel it worse. And them just feed me from morning. Jesus. But anyhow, so I'm actually using data on one of the devices because somehow I'm not able to connect to their Wi-Fi. The Wi-Fi is on the computer, but I should have. Wi-Fi is on the computer, but I don't have my plug-in headset, and my Bluetooth is not working for me to connect the headset to it. So I have to be using two different devices. But anyhow, so on my way down this morning, I was writing some questions for you, and then I felt sleepy, and I got here, and then from I got here, the day has been very up and down. I mean, I have the question. As promised, I was able to type the one that I did with you last night. But the ones that I wrote, calculus, the ones that I wrote today, didn't get a chance to type it. But what I'm going to do, though, we don't have much time left. It's just 1 hour and 20 minutes left. What I must do with you is to go through the one that we did last class, because we would have done some levels of differential equation from last semester. I know Tiana and I will have to have a conversation on this. And I want to spend a little bit more time going through this one here. And the reason is I didn't appreciate of all the questions that were done last semester, I think this was the most, the least answered question on the exam paper, differential equations. So I know I have to spend some time on it. So here goes. Here goes. My head hurts. I'm sleepy. And everything is that should be happening to me someday. Okay, let me share the screen. Yeah, trust me. I wasn't feeling 100 yesterday. I wasn't gonna come here today, but I was supposed to travel with these guys to another conference, and I backed out of it. And I said to myself, Lord, I can't back out of two of the conferences. Um, so I kind of pushed to come here, and then they never feed me, and my head is splitting, and I have an option to just stay here. I can call off the class. But last week Thursday was Holy Thursday, and there was no class, and I didn't see that. No man, guess what happened now, Josh? Last week I recognized three missed calls. I recognized one from the big man. I recognized one from you, and I recognized one from Yannick, I believe. But guess what? When the big man was calling me, me fast asleep. I said, sleep. And then when Yannick called me, oh God, me and sleep was having a good time. But yeah, there was no class last week. And I was sleeping it away. I only recognized it's not a matter of taking it serious. You know, the body really tells you that it's really very tired. So I went to bed from about, what time was class? That was Thursday. Class would have been 7 o'clock. I went to bed from about maybe 3 o'clock, 4 o'clock. And later on there sleep. Sleep for the whole thing, man. I was online though. I went to church Good Friday and Easter Sunday. I was online. And because I reflect, I reflected and no. That's fine. That's all right. Not a problem. That's fine. I missed the call because I was very much asleep. Oh yeah, tell me about it. Josh, you have to remember that question here, hon, because we see it out. So I remember. So you have to remind us the question, honey. Oh, yeah, that's true. And after the first, find the mix and all right. I can do that. I can do that over WhatsApp. All right. I can do that over WhatsApp. Not a problem. I don't want to be in the midst of the class. I'm using data on my phone for this. Let me see if I can connect it one more time. All right. So in the meantime, while I try to fiddle with this stuff, I'm connected on myself on my computer using their Wi-Fi. Let me try. Oh, come on. All right. So while I was preparing some notes for you guys, I recognize that I will be finished off with the differential equations pretty soon to start our final topic, which is our multivariable function. Multivariable function, that final topic is very long. I have the final unit, module, or unit, whichever you call it. There are like about 5 or 6 little topics inside of it. So even though it's the final one, we still have quite a bit to go. So let us see how best. All right, let's just go. Yeah, because this thing is coming up. All right, so we're looking at some differential equation, and I'm introducing a new term to you that is called the integrating factor, and we're looking at the integrating factor, and the differential equation given is dy by dx is equal to 5x minus 4xy. So dy by dx is equal to 5y minus 4xy. Now, what it is that we're using is variable separable. What we're using is variable separable. So remember, one can be my integration. I can't integrate with respect to y, but have an x on the side that I'm integrating with respect to y. Neither can I be integrating with respect to x and have a y on the side with it. So when I'm doing my variable separable, all the x's must be on one side and all the y's must be on the other side. It must be separate. And if it is not separated, it don't even make sense to start the integration. It is going to be wrong. One of the challenges that I have is I'm writing these questions out of my head and Yannick, please do not come in. And as I write the questions out of my head and I reach a point, I recognize that your syllabus does not require you to use trigonometric functions. Neither does it ask us to teach you to do integration by parts. And one of the questions I wrote today, when I look at it, it was coming out. I was able to do the integration to one side, but the integration to the other side would have been converted to a trigonometric ratio. And I said to myself, no. So I had to scrap that to write another. But yeah, I say this to say to you that the questions that you'll be given will be questions just on the variable separable. And the hardest one they will give you is a variable separable. And I did make mention of that to you last time around, that the first one, easy, straightforward stuff. Let me show you. Easy, straightforward stuff. So for example, they will say, find a particular solution for differential equation dy by dx is equal to 4x minus 2. Already, all the y's will be on one side and all the x's on the other side. So all I need to do is just drop this here. So come on. Put this over 1. My cross multiplication dy times 1 is dy, and 4x minus 2 times dx is 4x minus 2 dx. So you see I have all the y's on one side and all the x's on the other side. And when I drop the integration sign inside of it, all I'm going to have is just my function to integrate. It is a straightforward integration. For calculus, I was expecting questions like this for calculus 1. I can guarantee you that you're not getting questions like this for calculus 2. All right? And then we'll just go ahead and we'll integrate, boom, bam. And for general solution, we substitute what it is that they asked us for, what it is that they gave us, and then we can find a particular solution. Right? So those are what it is that we looked at for calculus 1. Pretty straightforward. All the x's are already on one side, so you're just going to have dy by dx is equal to 3x squared minus 1 dx. It is here. And you go ahead and integrate. These ones, on the other hand, are talking about variable separable. This was the first case where you have dy by dx is equal to a function in x or in y. And it's a straightforward integration. In the other case now is when the function looks like this. Case number 4 in some instances, and case number 2 in another instance, right? So let us go. That was just a very quick recap. So they gave us a differential equation, dy by dx is equal to 5y minus 4xy. And we're supposed to be solving. Now, if you recognize, you can see that I have both x and y on the right-hand side of my function. Matter of fact, are you all hearing me? I don't hear anybody breathing at all.
Yes,
you hearing
sir.
me?
Yes, sir.
Okay, good. So I have both x and y on the right-hand side of my function. Now, if I'm using variable separable, I have to correct that. How do I correct it? I have to correct it by putting some x on one side and some y on the other side. I can't have x and y together here. So the first thing I'm going to do, for me, once I see something that is common, factor it out. Every single time. Once you see something common, factor it out. Every single time. So if I look at this first term, I'm seeing 5y. If I look at the second term, I'm seeing 4xy. It means that my y's are common. So I'm going to be factoring up my y's. My y's are common, I'm factoring up my y. When I factor out my y's, I'm going to have y times 5 minus 4x. Now, this is where the trouble begins, because this y cannot be on the right-hand side. Impossible. So I now have to ensure that this y somehow gets over to this side. Oh, but sir, the y is being multiplied by the 5 minus 4x. And in order for you to get rid of the y, sir, you have to do the opposite of what the y is doing. Tell me, what is the y doing on the right-hand side?
Multiplying, sir.
Very good. And the opposite of multiplication is?
Division.
Division. So in order to get rid of that, thank you, honey. In order to get rid of that, I will now have to do the opposite to it, which is going to be a division. So what I'm doing is I'm going to be multiplying throughout by the integrating factor 1 over y. But sir, you just say what we're going to divide through by y. So we're going to talk about multiply. Dividing through by y is exactly the same thing as multiplying through by 1 over y. Can you see that?
Yes, sir.
So dividing through by y is exactly the same as if I am multiplying throughout by 1 over y. Very important that you see what does that mean. Dividing through by y is as if you are multiplying through by 1 over y. Driving. Do you understand that part? As something is wrong with me tonight. Do you see that part? It says, please note that dividing throughout by y gives the same result as if you are multiplying by its inverse. Please, sir, what is its inverse? Your inverse is going to be 1 over y. The inverse is 1 over y. Sir, how do you know that? Because it will become y to the minus 1. So the inverse is the same thing as 1 over y. So the inverse of 2 is 1 over 2. Inverse of 2 is 1 over 2. All right. So please note. Any questions so far? Guys, I want you to be with me now because this will come. And remember, every opportunity that I get, I have to remind you, remember, the series of these exams will be face-to-face, and I definitely have to maximize on its understanding. You're not going to have anything that you can refer to. All right? So let's go. Any question? Not me.
No, sir.
All right, thank you. And even if it's one response I get, I'm going to move on. All right. So what is going to happen now? What is going to happen now is when I multiply throughout by 1 over y, look at what happens. Now 1 over y is going to come over to this side. I'm multiplying through by 1 over y. And we end up with a 1 over y on this side. And this 1 over y is going to cancel this y. That's why I said to you that I'm multiplying by its inverse. So this 1 over y will cancel this y to leave only 5 minus 4x, which is this. I would have now accomplished my task. in separating my variables. So now I have my variable separable. Now I end up with my variable separable where all the variables of x is on one side and all the variables of y is on the other side. So this is where my variable separable comes in. Everybody can see where I have all the y's on one side and all the x's on the other side.
Sir, so what
Yes,
about
sir.
the dx, sir?
What about the what?
The dx.
Okay, you mind, very good. Yeah, we're not come to that one yet. So we're going to go to that one now. Thanks for asking. So Sash is asking, sir, what about the dx? Because I'm seeing a dx there, sir, but what keep with it? So you recognize now that we have 1 over y dy by dx equals to 5 minus 4x. So Sash is saying, but sir, you have an x over here. So I'm going to multiply through by dx. I'm multiplying through by dx. Oh. So when I multiply through by dx, sir, what is the difference? What are we going to get when I multiply through by dx? All right. If you see what is going to happen here, look at my line. I put all of those dx in blue. Look at that and tell me if you see what is happening.
Finally eliminate the dx, sir.
Very good. The dx finally got eliminated. The dx finally got eliminated. The dx finally got eliminated. So this dx in this denominator right here is now able to cancel out. So all I'm going to have on this left-hand side is going to be 1 over y dy. But on the right-hand side now, I'm going to catch up the dx. Oh, so when you multiply through by dx, sir, you're able now to magically transfer the dx to the right-hand side. Yes. So now I have a function in x and y where all my x's are on one side and all my y's are on the other side. Look at that. Tell me if you see, if you agree, because remember, I'm going to give you one to do in class today. Another one that I have written for you. Very nice one. All right, let's go.
Harder one, sir.
No, please do not follow Unique's bad behavior in agreeing that I give hard questions. No, Unique wasn't being nice. There's no truth to that. All right, let's go.
Not trouble you today, no, sir.
Bless the Lord. Bless the Lord. No, yeah, Thursday, sir. Oh, I hope I'm not tired because we'll come up on Thursday. So I want to man leave it from 12 o'clock. But anyhow, let's just see how much energy I have on Thursday. But no, man, you're good, man. You're good to go. All right. So if you look at it now.
Sir, sorry,
Go ahead,
Thursday is a mid-semester.
Oh, what did you tell me? Say? What I had said to you? Oh, yeah, I did say Thursday. All right. Let me just finish off this, give you the question. I want to work through that one question we do with us sitting on do some housekeeping. That's all right, Rush?
Sure.
Go ahead. Hello?
No, I said sure.
Oh, yeah. Let me just finish it and then we'll do some housekeeping afterwards. All right. So now it is that I have all my y's on one side and all the x's on the other side. I can now integrate. You can start integrating before you have separated your variables. Your variable separable must take effect first. And anybody that engage in that illegal act will get 0. Real talk. You have to first do your variable separable. Trust me, guys. I beg of you. Do your variable separable first before you start the integration. Now that I have completed my variable separable, I'm going to be integrating. So when I'm integrating, I'm going to have my 1 over y dy is equal to the integral 5 minus 4x dx. Pretty much what I'm doing is just dropping the integration sign right here. So in front of that, pretty much what I'm doing right here again is dropping the integration sign in front of here. So like that. So remember, last class we had a conversation that I had to go back into that repertoire. Tiana would also know about this because we would have done this in that other calculus course. When I integrate 1 over y, I'm going to get ln y. When I differentiate ln x, I get 1 over x. Differentiation is the reverse the integration, and you can't. Oh, that made a search all along. Oh, this is a liar. And you can't do anything before you actually go through with the separation of the variables. You must have your variable separable before you are able to do all of that. So remember, when you differentiate your ln x, you will always get 1 over x. When you differentiate your ln y, you always will get 1 over y. So remember that differentiation is a reverse the integration. So once it is that you undo the process, you're going to do the opposite. Because remember, the opposite of integration is differentiation. The opposite of differentiation is integration. So when the question asks you to integrate 1 over y dy, your answer is going to be ln y. Now, someone will say to me, but sir, you don't have ln y, you have ln the absolute value of y. Can somebody remind me why it is that I have ln the absolute value of y? We did it in calculus 1, so nobody should be stuttering about now. Why is it important for me to include the absolute value? Say it again, hon. There is a particular reason for me having that absolute value sign over my y. Why is it important for me to find ln the absolute value of y? What do you know about absolute values?
Sir, it's at the tip of my tongue, what I can't remember.
It's on the tip of your tongue, but you can't remember. Spit it off.
So I was saying the ln of any number is the number itself.
The ln of any number is the number itself? Not true.
0 and 1.
Check
Or
that.
the negative number is a positive number.
That's what the absolute value is. So when you take the absolute value of a number, it's always going to work out to be positive. So if you look at the screen, the absolute value of y, if you have a negative, okay, so let us continue with the conversation that you're having. The absolute value of y is going to be a positive number. All right. Why is it so important for me to have a positive number right there and not a negative number? I have said this over and over and over and over and over and over again.
So that it can't be a negative value, sir?
Why can't it be a negative value? What can't be a negative value? Why is it, okay, fair enough, so it cannot be a negative value. Tell me why is it so important that ln cannot be a negative value? Because the natural logarithm of a negative value is always
0, sir?
not 0, undefined.
Yeah,
Listen to me.
fine.
Listen to me. You hold on 1 minute, please, because I now remember the stuff. Right. So remember, you can't take you can't find a negative value of the natural logarithm because it's always undefined. Remember, so you can't. So the logarithm of a negative value does not exist, and that's why it's very important for us to always use the absolute value sign when we're talking about ln. Let me refresh your memory. Let us go back to some calculus one. I didn't delete these because
I was gonna say
Syntax error?
syntax error.
syntax error. When you get syntax error, it means that syntax means sentence construction error. So syntax means that it is an algorithmic error. You can't write it. So syntax is sentence construction. So it means that there is no way you can construct ln -3. That does not make any sense. You can, however, construct ln the absolute value of -3, because the absolute value of -3 is going to be equal to +3. The absolute value of +3 is +3. So when you can now find the absolute value of +3, which gives a positive number. Now let us go back to what Yannick said to me earlier. When I find ln of 0, whoops, what value do you get here? Put in the calculators ln 0 and tell me what you get.
Math error.
Math error. Put ln 1 and tell me what you get.
0.
And ln 2, 3, 4, 5, 6 will give you different values of ln. Different values. All right? So it's not a constant value. The values are going to be different. But just remember, the logarithm does not exist for the negative values. You won't have any negative values of the logarithm. It does not exist. And the logarithm of 0 is going to also be a math error. It don't work. And sometime later we can investigate what Desmos, will say about it and how Desmos looks at it. All right. So what is going to happen is, if you look up here, when I integrate 1 over y, I'm going to get ln y, but it's not just ln y, but ln the absolute value of y. There's another question, and it goes to all the questions that we would have done, teacher. But let me ask you though, why is it? The question gone. Hold on, let me think. Oh no. Oh yeah. Why think that I had to put the ln y there, even though that they don't, I don't know what the values are because it's an indefinite integral. It's an indefinite integral. So why is it that I had to put the absolute value of y right there? Let me see if you remember. If you don't remember, don't let us waste the time. Just say you don't remember. Why I had to put ln again, one. Go again, Yanni. All right, so I think my internet is going. Anybody else hearing me? Is it my internet or is it Johnny's internet?
It's Yannick, sir, Yannick.
Oh, okay. Come, Yanni, talk to teacher again. All right. Anybody else can maybe see what it is that she was going to say or has an answer that you can tell me?
So repeat the question.
I'm saying to you, why is it that why is it that I had to put the absolute value sign? Okay, yes. So we know that we can't take the logarithm of a negative number. All right, hold on. Let me preserve something here, guys. Sorry. Recording in progress.
All right, so I finally got connected to the Wi-Fi, so I'm saving some data. I may want to watch TikTok on my way back to Kingston, God's willing. All right. So I'm asking, by the way, can you hear me through this new device?
Yes, sir.
Loud and
sir.
clear.
Loud and clear. All right, nice. I'm notorious to come and these people place and leave my little devices. So I have to put them up as soon as I use them. All right. So what I'm saying to you is, I'm asking, so yes, so we can't take the logarithm of a negative number. But why was it important? Why was it important for me to again, to use the absolute value sign? Why was it again important for me to use the absolute value sign? There's another reason. There's another reason for me to be using the absolute value sign. Can anybody tell me why?
I don't remember, sir.
All right. It's very important because remember it's an indefinite integral. It's an indefinite integral. I don't know what an upper or lower limit could be. Now, what if the question asks me to find something more specific, giving me the same question, but giving me a limit or giving me limits that one of them is negative? So it's important for me to put that sign there so that whoever is doing the question or evaluating something at that point will recognize that if one of the limits is negative, I have to find the absolute value of it. It's very important. Very, very, very important. So always remember when you're looking at your signs that you're going to be looking at the absolute value of the function of the logarithm. All right. All right. So with that said, and you understand why I have to use the absolute value. Two reasons. Absolute value because I cannot find the natural logarithm of a negative value. And the reason that I have to put it there is because I'm not sure what the limits of the function would be because it's indefinite.
Sir, question.
Go ahead.
Is it because you integrate that set why the dy is now gone?
Very good. Very good. Yes, ma'am. Not only the dy is gone, you know, something else is missing.
The dx too. The dx.
And something else too. The sign of integration, you know,
Yes.
the sign of integration gone too.
Yes, sir.
So that's when you know that you have integrated. Once the sign of integration is gone, you know that you have differentiated, integrated. Once the sign of integration is gone, you know that you have integrated. It's very important. Very, very, very important. All right. And then no, the other side is easy to integrate. When I integrate 5, I'm going to get 5x. When I integrate negative 4x, I'm going to get negative 4x squared over 2. Remember, you always add 1 to the power and divide by the new power. And remember, once we are integrating an indefinite integral, we must put our constant of integration. You don't have a choice. So it go, and so we have to keep it. Once it is that you're integrating an indefinite integral, you must have your sign of integration. If you don't have the sign of the constant of integration, sorry. If you don't have your constant of integration, your integration is incomplete. And you cannot get full marks. Then, sir, for one little C, you take off mark? Absolutely. If you're supposed to get radiation therapy, and the man them said, sure, you're supposed to get 25.4. You just go give him 25. It means the therapy is not going to be effective because you don't have the required amount of concentration. And if you say 25.4, that's almost 26 here. I'm just going to put it up to 26. The man dead or the woman dead. Right? So you have to have that keen eye to detail. And then it did say to solve. Now, when I'm solving my differential equations, I don't want ln y, I want the value of y every single time. Yep, every single time. So because I have ln y, I'm going to take the natural, the anti-natural logarithm I mean, it's the anti-logarithm of both sides. What do you mean by anti-logarithm, sir? It's like the inverse. So the inverse is not like the inverse, it is the inverse. So the inverse of ln is 1. But the inverse of something else is going to be the exponential function. So one is the reverse of the other. All right, so look here. So I'm taking the anti-logarithm of both sides. So when I do that, I'm just going to get y. Then, sir, why don't put the absolute value? I don't have to put the absolute value sign there anymore. Why, sir? Because y can take any number, no. Y can take positive number, it can take 0, and it can take negative number. Oh, so is it because I don't have the ln function in front of it? Absolutely. So y now is able to take any one of those numbers. Any one of those numbers y is able to take. All right. Now let us look at it. So allow me to. Yeah, I didn't put it like that. So when I'm taking the anti-logarithm of both sides, I'm just gonna raise my 5x minus 2x squares as a power to my exponential, and my plus c is always my plus c, my constant of integration. Are we good with that so far? Do we have any questions? It's so long I spent on this because I expect you to get this. This is a recap of what we did last week, Tuesday. Yeah, it's a recap, and I want you to make sure that you get it.
Oh, will it get harder, sir?
Sure.
It's not going to. I promise you. Yes, Lexon, you're calling Lexon?
No, Christy. You can scroll back up.
Oh, sure.
All right.
Further up.
The only thing me not get so far is where the x square came from.
Oh, when I'm integrating 4x, it's going to be 4x squared. I always add 1 to the power and divide by the new power. Always add 1 to the power and divide by the new power.
Oh, so that's okay. All right.
Sir, you can go to the top so I can snap picture when you're doing that.
You want me to go to the whole? You want me to minimize it so you can see the whole thing?
Yeah, yes, please.
Yeah, man.
Yes, you're sending this as well, right, sir?
Yeah, man, I will.
Okay.
I didn't set it the last time because I needed to type it. I only typed this last night while I was doing some preparation for tonight's class.
Okay.
DSC husband, are you with me? Are you understanding what is happening? Or I need to reduce it some more. Are you understanding what is happening? Oops. Mr. Campbell, you're not answering me?
Oh, I don't know what speaking to me, sir. What did you say, sir?
I said DSC husband. It's one big family now, you know, so you can't hide, you know. All right, bless up. All right, so snap that for me.
I understand.
You understand, nice. Now, remember, for the differential equations, I suspect that they may give you 1, 2, or maybe 3 of them. No, maybe not 3, but they may give you about 2 of those questions, and each question can come to about 7, 8, 9, 10 marks, depending on the difficulty level of it. And remember, each question is weighted 20 marks. You have 3 questions, 3 compulsory questions to answer, 20 marks each, and 20 multiple choice questions. So you have to be very mindful of that.
So face-to-face answer? So face-to-face 3 compulsory questions?
Kimmy, what you were saying? Sorry, not Kimberly.
Yes, my name is Kimberly too, sir. Yeah.
No,
But-
Sash, I never meant
Yeah.
to call it Kimberly a while ago, no, but I etched in my headspace is your WhatsApp thing. So that's why I said Kimmy. Sorry, Sash, go ahead.
All right. I was saying if it's 3 compulsory for section D for face-to-face.
Not only face-to-face, it's the same thing for online. Remember, it was 3 compulsory questions.
No, man.
No, sir, the past
man.
year they have 2 questions,
2.
sir.
No. Okay, let me clarify. Let me clarify. What I'm speaking about is I'm speaking about this new face-to-face sort of hybrid approach. That's what I'm speaking about. Originally, you were given 3 questions to answer any 2, but those questions were 30 marks each. All right. The older papers, the much older papers, would be 25 marks per question. And you'd have been given 3 questions to answer any 2 questions. That would be 50 marks, but you would have gotten 30 multiple choice questions.
Actual.
Right. And the paper will be marked out of 80. So in the old face-to-face approach, 2 questions out of 3, 25 marks each. As a matter of fact, I think, let me see, we give 4 questions. Those were the days. Let me
4
see.
questions, I choose 2.
And you choose any 2 for 25 marks and get 30 multiple choice. But my good golly wow, the multiple choice were so difficult to come up with. So what we do, they increase the marks for the essay paper. And they started giving, 3 essay type questions at 30 marks each and 20 multiple choice. But I'm saying to you, for this face-to-face / online sort of hybrid approach, it's going to be the same thing as for the online that we had for online. We got a compulsory paper, 3 questions at 20 marks each, that's 60, plus your 20 multiple choice, making it up to 80.
All right. Once the point Microsoft, everything good, sir. Everything good. Once the point
Remember the man them said them going back to face-to-face.
So hold on a second. So is it that the entire schooling thing will go back face-to-face or just exam alone?
No man, you notice we are having our online classes. No man, we're online, man.
Yeah.
Sir, we won't go about the face-to-face class.
No, so I can't manage that. Can't manage that. Me work too late, so I can't manage that face-to-face thing there.
Yeah, but the exam though, for sure, the exam is going to be on face-to-face.
So teaching is online and then exam is face-to-face.
For this semester, I don't know what will happen for next semester. The minister is here, and the minister spoke shorter term just now, earlier on today. So I think to say COVID now keep again because everybody, all right, I'm typing the question while I'm talking to you, so I'm multitasking. I am here and I'm walking up and down and I'm seeing guests sitting in areas not wearing a mask. And it's not that the mask is even visible under them chin. No, so me I suffocate under my mask. Because all when COVID done 3 years from now, so me still under my mask. Me have to know say it done fully before me come out of my mask.
COVID now done.
And that's the point.
Andrea plan for next wave.
All right, that is another conversation that you will have outside of this class. No, but it's serious, and now I'm hearing that tuberculosis has broken out again. So let us see what will happen.
Yeah, currently at chest right now, I think.
Yeah, man. All right. You know what? Before any of you start to squeal, let me just check the question. All right. Before any of you start to squeal, we're going to do that question, but let me just put another question.
Yeah, you know, so you're plan for you know.
No. It's just that I don't want persons to say me give the easy question here. So matter of fact, make it stay. Make it stay. The other question that I have is something similar to it. So let it stay. All right. So let me help you through something here, though. Let me help you through something here. It says solve the differential equation. And I did it like this because I want to preserve the solution for the first one. So at least you still can see what is happening. Solve the differential equation dy by dx is equal to 6y to the negative 3 power. That's what I have, yes. Plus 4xy raised to the negative 3rd power. All right. Now, so you have that differential equation. Let me see if you can hazard a guess what will be my integrating factor. Now remember, my integrating factor, okay, before we go there, let me make it easier for you. What am I able to factor out?
Y
-3.
There you go. Right, I'm able to take out a 2, yeah, I agree, I'm able to take out a 2. But in this case, you see, Yoni, that I'm not really interested in the 2 just yet, right? But you are correct, you're very right. Good, but tell me now, so I'm able to take out a y to the 3rd, all right, a y to the 3rd.
To the 3rd or to the negative 3? All right,
I said that to see if you're paying attention, because it is to the negative 3 power. But as I said, I only said that to see if you're paying attention. I know you're paying attention. Very nice.
Or with me write things on the exam paper, me just to see if you on point, you know.
Yes, man. Yes, Miss Shana. You're good. All right. So, sure. Young boy, go easy now. Sure. All right. All right. So the young boy complaining that his eyes are failing him. So I'm going to zoom in just a little bit more. I wonder if I do this, you will see it. If I were you, I'd focus more on the calculus too, because you know, they might go on if you have the degrees, they can buy the Gucci. So looks narrowing again, you know, the pretty woman them know have some very interesting looking men. Prettiness now look on it. The girls them want to make sure say them can have it. Them no. Sweet boy. I'm so glad I come out for the market. Come in and know how much I manage. Okay, let's continue. Because you've been stamped your pride about now. All right, Jermaine, I'm trying to do something here so that we can. Is it better for you, Jermaine? Can you manage this one? All right, nice. Nice. All right. So let me ask one more question before I ask you to start working on your own. So y to the negative 3rd power is common. You can factor it out. What, therefore, would be my integrating factor? Please think about it before you answer. Think about it first before you answer. What would be my integrating factor?
1 over negative y 3rd.
Very nice. And that can be written as what?
Square root Why? No,
Mm,
no.
Listen to what Lexton said a while ago. Say it again, Lexton.
1 over y negative 3.
1 over y to the negative third power. Okay. Convert that for me, please, and give me something nice. So 1 over y to the negative 3 is the same thing as? Anybody help him?
Cube root of y, I think.
If I knock you to see, sure.
Sir, wouldn't that become y to the third power?
Very good. Come on, Lexton.
Yeah, take away the positive. I was thinking about that. Taking away the positive.
You see it now, Lexton?
I jump in late, you know, sir. I just see that.
No, you're jumping late, but you're jumping with the correct answer right there. So,
Yeah.
but you have to forget about the little simple indices. So 1 over y to the negative 3 is going to be the same thing as y to the positive 3 power. Remember? So what you're doing, which is really the inverse of y to the negative third. So so I just helped you out with the integrating factor. Go right ahead and continue with this for me now, please. Thank you.
Sure.
Yes, Sash.
All right. So if I'm going to factor out y to the negative 3, right? Then I'm going to multiply it through with 1 over y to the positive 3. How am I going to cancel out the y on that side?
Because you're multiplying through by y to the negative y to the third power. So you're multiplying throughout the whole equation by y to the third power. So you're going to end up with y to the third dy by dx is equal to 6 y to the third y to the negative 3 plus 4x y to the third y to the negative 3. So you're multiplying throughout the question with a negative 1/3. Sorry, with a positive 3. You follow what I said a while ago? No? You're multiplying throughout the whole equation by y to the third power.
Okay.
Are you okay? You understand what I just my answer to you, right, Sash?
I think so.
Okay.
Mr. Sir, I something like that me that do a while ago, and then when Sasha asked the question, it got me mixed up.
No, man. You have to have the confidence, man. Maintain your confidence. Continue working. So I'm working as you're working because I didn't type the question. So I'm doing it just now. Where am I? Six plus 4x. All right, so I leave it up to the second to last line. We just have one more line to write.
Okay, so you multiply 4 by both sides. Okay.
Tell me why I multiply both throughout by 4.
Okay, you want
Because I want what?
leave that to somebody else.
Why did I multiply throughout by 4?
Because you want to leave the y.
4.
Yeah. So you want to know, on a fraction that or something like that, maybe.
Yeah, but yeah, what do I always try to get alone on the left hand side?
Y by itself.
Y by
Y.
itself. Good. So because it's a fraction, I'm multiplying whatever the fraction is. So I can get rid of the fraction. So the fraction is going to be 4. Sorry, y to the 4th over 4. So I'm multiplying through it by 4. So when I do that, I will cancel out that 4 in the denominator. Now I have y to the 4th. Do I need y to the 4th as my final answer? Or do I need y?
Just need y.
Very good. What do I do? What do I do? Talk to me.
Sir, the 4.
Oh, because so you find the square root of
The 4th root,
yeah, the
not square.
fourth root. Fourth root
Yeah.
of so you find the 4th root of y and also over by the and also on the next section. Something like that. Okay.
Whatever you do with one side of the equation must be done to the other side of the equation. Whatever is done to one side of the equation must be done to the other side. Any questions? All right, so I'm here in the heavy side. Talk to me. Because I'm going to give you one for homework. We have 10 minutes. I want you to use the 10 minutes and talk to me. Why the heavy side? What seems to be the challenge?
Oh no, that was me. My bad.
No. I'm not. I mean, it is indicative of something. It is saying to me that there's something that you're not seeing. And I'm here asking you, what is the challenge? What are you not seeing? Talk to me.
Sure. So at any point you have a power, the variable raised to a power, you turn the right hand to a square or whatever root.
Yes, ma'am.
Just
So
that
it
one,
was-
sir.
if it was y squared, you're finding the square root. Y cube, you're finding the cube root. Y to the fourth, you're finding the fourth root. Y to the n, you're finding the nth root.
I'll say so whatever the power is, you just find the root of that power.
Yes, sir.
Alright. So the last part where I say I have y equal e and then the equation in superscript plus c. Like that, right? That's all.
Mhm.
So that what is the answer below just reflects that, right? That's all right.
Right. And the only reason you can get an exponential function now is because when you integrate it, you got a ln function. So that's what I'm saying to you. You can identify them easily. So if when you integrate and get the ln function, the natural logarithmic function, it is not problematic because all you will now need to do is to take the natural log, the antilog of both sides. But in this here case, in example number 2, there was no log at all that came up. So we don't need to take no antilog of nothing because we never have no logarithm in the first place. So as such as anything that the power is raised to, that's the root that you're going to be finding, because remember, we don't want our answer to be y to the fourth. If you write your answer as y to the fourth equals 24x plus 8x squared plus c, you only get pieces. Well, you get enough of the answer, enough of the marks, but you're not going to get the full marks.
Sir, what's the difference between the 1 over y and y not 1 over y to the third power?
What are you talking about? Right here, sir?
Up top, sir. Yeah.
Yeah, because
Wouldn't that be like y minus y raised to the negative third power?
if it was y raised to the negative third power, it would be 1 over y to the third. 1 over y to the third, yeah.
Yeah, I think that should have asked 1 over y to the third.
Yeah, but remember, we agree that the integrating factor is going to be y cubed. I need to multiply through the equation by y cubed in order to get rid of this y to the negative 3 on this side. Remember, when we are separating our variable separable is saying to us that we need to get all the x's on one side and all the y's on the other side. That's what our variable separable says. So whatever we're doing, we need to get the variable separable like that. All the x's on one side, all the y's on the other side. Talk to me.
I see it now, sir.
Yeah, man. Any other questions?
Housekeeping, sir.
Oh, goodness. This is you, sir? Not at all. And I'm finished with you. I'm just going to sort up myself so I can go get me some well-deserved food to eat. All right. What I'm going to do, if there are no other questions, I'm going to, as I said before, I wrote, I have another 2 questions. Is this 2?
No,
Yeah,
sir,
whatever.
you said that you're gonna do some housekeeping matters.
Oh, I thought you were talking if I was calling housekeeping. Oh,
Oh no,
all right.
sir.
Yeah, man.
That's why I was laughing. Okay, so I apologize. Yeah, so the housekeeping for me is so Thursday is the 21st. It's one of two things. Let me give you two options. Option one is that we do the mid-semester on Thursday. Option two is that I have class on Thursday and well, the point is, let me give you the option to do that. The second option is you suggest a day before Tuesday, the 26th, that we could have the mid-semester, a day that is suitable for everybody, that we could have the mid-semester. So it's one of two things. One, I can do the mid-semester on Thursday coming, or two, I will have you maybe not in this session, but you can discuss it over WhatsApp. I give you the option of deciding which day between now and before Tuesday next week, we will do the mid-semester. So I give you that option. And it has to be an option where all of us will be doing the test on that day. So I can't say, okay, sir, let me do it tomorrow, or let me do it Friday. And somebody says, sir, I want to do mine Saturday. And somebody says, sir, I want to do mine. It will have to be a day that is agreed, upon by everyone. So it could be a Saturday evening exam, maybe 6 o'clock to 8 o'clock. It could be a Monday morning exam, Monday afternoon exam, but anytime you decide. We don't have to do it now. Anytime before. Why? I don't want, there are several things that I have to go through and I don't want to give up my class time. And especially that come Thursday, all being well, it's 3 hours. I would have missed 3 hours of you last Thursday. So I really need to make up those lost time, those 3 hours. That's the point I'm making. Talk to me now. What do you think?
Sir, yeah, man. So, Sunday night or Monday morning. Well, somebody said no to that. What Sunday is good?
All agree for Sunday?
Yes, sir.
Let me tell you what I don't want to
Yes,
happen.
sir. Yes, sir. Sunday is all right.
All right, so somebody says Sunday is not good. All right, so we have to find a day. Now, let me tell you what is going to happen. I had a student some time ago. I threw out something to the class. We agreed, this same calculus 2 group, not this same class, same course. Threw out something to the class and I asked the students to decide on what to do. And it came back to bite me. So I want you all to decide which day of the week you're planning, that's fine. Which day of the week you're planning, you want us to look at it. You tell me, I will work with it. All right, we don't have to discuss it here because it's now 7, we don't have to discuss it here. Let me see the active conversation in the WhatsApp group. Let me see the final decision in the WhatsApp group because it has to be done before Tuesday. I cannot give up my time on Tuesday and Thursday because looking at it, next week is the final week of April. So thanks for showing up. We'll send you the notes.
And the topic, sir, please.
Yeah, but remember, it's unit 1. So everything that covered unit 1 is what it is that will be tested on. The McLarens, the estimation, you know what came in unit 1. So anything that, say it again.
Newton-Raphson or
Newton-Raphson, yeah. Anything that came in unit 1 is what it is that we're going to be tested on.
All right, sir.
Yeah, man.
Good night.
But yeah, but importantly, before you go, Sash, importantly, you know, and again, I'm going to say to you, the end of semester exams will be face-to-face. It means that you will be required to take the information not on paper, but in your cranium. So we have to be working and working very hard from now. So those of you who are not putting to memory the things that we have done, now is a good time to start working as you are preparing for the mid-semester. All right, thanks for coming out. See you
Sir,
all.
I'm going to voice note that a concern to you.
I have no problem.
And
No
I'm
problem.
gonna call it, sir.
I have no problem. Anybody else want to talk to me? Side talk me? Not a problem. All right, let's up. Have a good one.